Good afternoon, Year 4, and here is your science lesson for Tuesday, the 23rd of February. You'll notice that the date and WALT aren't on the screen at the moment because instead I'm sharing our new cover sheet. So if we were in school, we'd have stuck this in, but it does just show that we are changing our science unit. So this term we will be looking at states of matter. I'm sure when we finally get back to school, we will go over some of the sound unit that we did do completely remotely, but I do want to start and have a look at this one with you as well. So if you want to pause the video and have a quick look at some of the objectives and think about where you are, obviously you can't mark where you'd be on the learning pit, but we are going to be learning to group materials, knowing that some materials change their state when they're heated and cooled and things like that. So for this lesson, we're going to be describing the properties of solids, liquids, and gases. And lesson 1 up here, this should say this is for Tuesday, the 23rd of February, 2021, in case you want to pop the date in your book. Okay, so let's get started. What do you already know about solids, liquids, and gases? What properties might they have? What can you tell me about them? If you can either think about that if you're at home or chat to someone if you're with Mrs. Chamberlain in school, and then just think about where you'd be on the learning pit starting at the beginning of the lesson. Okay, so we're going to start with a true or false then this morning. All things are categorized into solids, liquids, or gases. What do you think about this statement and why? Do you think it's true? Do you think it's false? Do you, or if you're in school especially, can you build on or challenge someone's idea? Can you think of something that doesn't fall into those categories maybe? Okay, so sorting materials. Can we please sort these materials into solids, liquids, or gases? So we've got oxygen, wool, rock, cola, sugar, rain, hot air, glass, cardboard, clouds, and clay. So think carefully about each one. You can discuss it with a partner if you're in school, or potentially with someone if you're at home, but if not, just have a think about it, and you could create a list on a whiteboard. If not, we can just drag them together in a minute. So I'll give you maybe a minute or two to have a think about these. Okay, so oxygen, hopefully we realise that that's in the air around us, so that's going to be a gas. So I'm just going to pop that one over to this side at the moment. Wool is a solid, rock is a solid, cola is a liquid, so it's a drink, so it's a liquid that goes in there. Sugar is a solid, clay a solid, clouds are going to be gas. Tricky that one because it could be liquid when it falls out the clouds, but the clouds itself, those particles. Cardboard is a solid, glass is a solid. What does it have over here? Rain is a liquid, comes down in liquid form. Most of the time, you could argue hail comes down as a solid. Oxygen we've done. Oh, and the hot air for the hot air balloon is gas. So hopefully you had a good idea at some of those. Don't worry if you didn't get them all right though, because we're going to learn what those words mean. Okay, so properties of solids. These items here are solids. So you can see the picture. What do you think they have in common? So you've got glass, sugar, the wool, a can, rock, sand, a magnet, ice, looks like a sponge, an ice lolly, Lego, clay, and then some kind of cardboard and a wooden statue. What do you think these things have in common? And hopefully you'd have said something like this. So materials in a solid state keep their shape unless a force is applied to them. Solids can be cut, squashed, or twisted. They will not change shape on their own. So something solid I have with me here is a pen. It keeps its shape. It's still a pen shape, whichever way around it is. Only will it change its shape if a force is applied to them. So if I was really strong, I could push and I could bend it, or I could cut the pen or squash it or even twist it. But it won't change its shape on its own. Even if I drop this, it's not going to change its shape. And solid materials always take up the same amount of space. They do not spread out or flow. Solids don't have to be hard. They can be squishy or soft. So you could have blue tack or Play-Doh, which is squishy, but it's still a solid if it doesn't flow anywhere and it doesn't change its shape. Okay, let's have a look at liquids then. Here are some items of liquid. We've got rain, we've got a cup of tea, a cup of coffee, glass of water, soup, honey it looks like in there, Coke, lemonade. So what do those have in common? Okay, so material is a liquid state materials in a liquid state take the shape of the container they're in. Although liquids can change shape, they do not change their volume or the amount, and this means that they still take up the same amount of space. Liquids are pulled down to the bottom of a container by gravity, and liquids can flow or be poured. So I've got a bottle of juice here. You can see it's taken the shape of the container or of the bottle, and it would move, it flows. Oh, it would pour. Don't really want to pour it here though, but it takes that shape. And if I poured that liquid out into a washing up bowl or something, it wouldn't change the amount of liquid, it would just spread out into a different shape. Okay, gases then. Some of these things are gases. So you've got that picture of oxygen going up the girl's nose there. You've got steam from a kettle, bubbles. You've got the air particles in a sponge, and you've got the hot air that goes into a hot air balloon. So what do you think those things have in common? Okay, so materials in a gaseous state can spread out to completely fill the container or room that they are in. Gases have weight, but can be squashed, and they cannot keep their shape. So I don't have any gaseous things I can show you. Didn't really want to boil the kettle just to show you the steam, but there is gas all around. And you can't feel it, but it can be squished. And even though you can't see anything of squishing particles here, making them smaller, but they don't keep their same shape, but they do have a weight. And we're going to find out a bit more about that in the next couple of lessons. Okay. So properties then. Let's find out a little bit more about the video, and then we're going to be able to sort some of those statements from what we've just learned. And fingers crossed you can see this video as I play it.
All right, what have you got there? You've each got one of the 3 states of matter: solids, liquids, and gases. Solids, like this block of ice or this ball, retain their shape and volume. You can hold them and cut them into pieces, and they always take up the same amount of space. Liquids, like water or honey, can flow or be poured, and they're pretty tricky to hold. They change shape depending on the container, but always keep the same volume. Gases are crazy and don't keep their shape or volume. They spread out and can fit any container they're put in. Often you can't even see them. Gas is put into some drinks to make them fizzy, and when we drink them, that gas can sometimes try to escape from our bodies. Oh, delightful.
Okay, so hopefully that told you a little bit more than me reading the information. So there are some statements here on the left. There are 6 statements. I wonder whether you can think about whether they go into the solid, liquid, or gas, and how we can describe them. You can pause the video and have a go, and then we'll go through some of the answers. Okay, let's have a look then. So spreads out to fill a space. Do we think that's a solid, a liquid, or a gas? And hopefully you thought a gas as well. Takes the shape of the container it's in. Now that was a liquid, and I just need to make that a little bit smaller to fit inside. There you go, my box. Keeps its shape is a solid, can be poured is a liquid, does not have any fixed shape, a gas, and can be cut, squashed, or torn in the solid. So hopefully you're able to sort those fairly simply from what we've just seen in the video and what we've known on the previous pages. Okay, particles then. So I've used this word once or twice, and it was in the video as well, but let's learn a little bit more about particles. So it says we can explain the differences between solids, liquids, and gases by knowing what they are made of. Scientists have found out that all materials are made of very tiny particles. These particles are so small that we cannot see them with our eyes or even with a microscope. The position and behavior of the particles is different in solids, liquids, and gases. So we're going to have a quick look at this video as well. And again, if these links don't work for whatever reason, I will just copy and paste them so that you can watch them.
Most gases are colourless, but not all. In this very cold sealed tube is a solid called bromine. As it warms up, it melts and becomes bromine liquid. As it gets warmer still, the liquid evaporates and forms brown bromine gas. The same stuff, bromine in different forms. Matter, the stuff that everything is made up of many tiny particles. The behavior of these particles is what makes a substance a solid, a liquid, or a gas. In a solid, the particles are packed closely together in a rigid structure, vibrating about fixed points, but unable to move around. In a liquid, the particles can move around each other, so the liquid has no fixed shape, but they are still very close together. But in a gas, the particles are spread far apart, moving around rapidly and randomly to fill the entire space.
Okay, so you saw those little bromine characters, and it's described again using these pictures here on the left. So it says scientists have used these images to describe the particles in different states of matter. So just like we saw when that bromine character opened the first door, all of the particles are closely packed together in a regular pattern, and they vibrate and they move on the spot, but they keep their shape unless a force is applied to it, and they remain the same volume. The next door that bromine character then opened was the liquid room, and it showed that the particles are close together but random, so they can move around. They can move over each other, and they take the shape of the container it's in. Again, it stays the same volume. Then the final door that bromine character opened was the gas, and the particles spread out and can move quickly in all directions. So you saw they were separate and they were flying around that room wherever they wanted to. They don't keep their shape, and they can spread out to fill the shape they are in. And you can see just over onto the left-hand side there, those three pictures that show those particles. So the first solid, all of the balls are close together. The liquid, they're quite close together. You could draw them even slightly close together, but they're moving. And then the gas, there's very few of them, and they are more spread out. Okay, I'm going to watch one more little video about states of matter. And it says, whilst you're watching, see what materials you can spot and what states of matter they are. And again, if this one doesn't work, or if the others have worked or haven't worked, I will post this one as well. So Emmett thinks that he knows what a solid is and a liquid and a gas. And he says, I know that a solid has a solid shape and solid particles, and a liquid and gas can both spread out and they have less solid particles. Do you agree or disagree with Emmett? Especially on the last two, the liquid and gas. If you want to pause and have a think about that and try and explain why he is kind of correct, but his explanation needs a little bit of detail or a little bit of change, you can definitely do that. For today then, your task is going to be to find some examples of each state of matter, and you need to find at least 3 examples for each state. So on my example here, you've been given this grid, and I've got examples in the classroom here, but on your sheet at home, it just says examples. And I said I found a book. So I've drawn a picture of the book in my examples, and I've written the word book. You then need to find 3 in there. So you don't have to choose book. You could choose the pen that I was talking about earlier. So again, I'm really sorry drawing on here, but this is the pen I held up a minute ago. It's a very bad looking pen that I've drawn there, and you will choose 3 to go in that box. Then 3 liquids and then 3 gases. You might not be able to actually see the gases, especially when you're around your home or in school, but I'm sure you can definitely think of 3 examples. Then for the go deep, it says to please draw the particle arrangement for each and think about those images. So I've got a particle arrangement there. Do you agree that's in the right place? It's not quite, is it? So that's actually the liquid particle arrangement. So you'll have to draw the correct one for the solid and then for the gases. And then for your go deeper, it says, can you describe the particle properties for each state of matter and try to include the scientific vocabulary you have learnt? So if I just go back and show you here is exactly where we've labelled the properties in each of those states of matter. So if you need to rewind the video and go back to this page to have a look while you complete your sheet, that's absolutely fine. But remember to use some of that scientific vocabulary when you fill in that last part. I wish you lots of luck today and hope you enjoy going around your home or around school in the classroom to try and find some of those states of matter, and just come back at the end for the learning pit. Off you go. Okay, huge well done for having a go at that today then. Have a think about what working scientific skill you might have focused on today, if you want to have a look at those and think what did you actually do when you were looking around your home or around the classroom, and then think about the learning pit. So what new vocabulary have you learnt today? Were you surprised by any of the states of matter? And where do you think you are on the learning pit? You're more than welcome to draw one on your work if you'd like to, because it's always lovely to see them when you send your work in. And I do look forward to seeing some of your science work if that's what you choose to send in. Well done again for today, and I look forward to seeing you next week for some more science. Bye for now.